Here, our goal is to calculate the size of angle A. Notice here that angle A is inside of this triangle. And notice here that each side of this triangle has a line or has a stroke on it. This indicates that all of the sides of this triangle are equal. And since all of the sides of this triangle are equal, that means that this triangle is actually an equilateral triangle. Indeed, since it's an equilateral triangle, not only are all the sides equal, but all of the angles are equal as well. So if this is angle A, then that means that if this is angle A, then that means that this angle is also angle A, and this is also angle A, because all of the angles inside of this triangle are equal. Here, we're going to use a useful geometrical rule, and the rule states the following. Angles in a triangle add up to 180 degrees. And so that means if we add this A plus this A and this A, we should get 180 degrees. And remember, each of these angles are equal. And so we're going to take 180. In order to find A, we're going to take 180 and divide it by 3, because there are 3 angles in this triangle which are equal. Then we say 180 divided by 3. 180 divided by 3 is 60 degrees. And so what that means is, that means that this angle right here is 60 degrees. This is 60 degrees right here. Okay. And this is also 60 degrees. So each angle in this triangle measures 60 degrees. And so that means the size of angle A is 60 degrees. Let's move on to the next question. It says, calculate the size of angle B. Note from the previous question, we know that angle A is 60 degrees. We also know that every other angle in this triangle is 60 degrees. Now, our objective is to determine the size of angle B. Now, if we look carefully, angle B is on the side of this angle that measures 60 degrees. Indeed, we can use this geometrical rule, which says angles on a straight line add up to 180 degrees. Notice that here we have a straight line, and both of these angles are on the straight line. So they're on the straight line and they're at this common point. So that means that 60 degrees and B, if we add them up, it should be equal to 180 degrees, because they are two angles that are on a straight line at a common point, and they should add up to 180 degrees. And so in order to determine the size of angle B, we're going to take 180 and subtract it with 60. And 180 minus 60 is definitely 120. And so that means that the size of angle B is 120 degrees. Next, our goal is to determine the size of angle C. Notice that this angle right here is 60 degrees, and we found it out from the previous question. We know that this angle is 60 degrees because that was the first question that we did where we found it out, recognizing that this is an equilateral triangle. So all sides are equal, all angles are equal, and each angle measures 60 degrees. And so that means here is 60, here is 60, and here is 60. And so if we note carefully, this is 60 degrees. Notice here that we have this box, and the box indicates that this is a 90-degree angle. Okay, so the box indicates that this is a 90-degree. And our goal is to determine the size of angle C. All right, our goal is to determine the size of angle C. So we have 60 degrees C, and we have 90 degrees. Note that we have a useful geometrical rule which states that angles on a straight line add up to 180 degrees. Indeed, these angles are on a straight line and they are at a common point. And so that means if we add 60 plus C plus 90, it should add up to 180 degrees. And so that means in order to figure out the size of angle C, what we have to do is we have to add 90 and 60. So we got to add 90 and 60, and then we're going to subtract that sum from 180. So we have 180 minus 150, and 180 minus 150 is 30 degrees. And so that means that the size of angle C is 30 degrees.